Hello students, in this video we'll discuss about input buffering. So in the previous video we have discussed about the lexical analyzer roles. So where the input is going to be converted into tokens, but how this input will be buffered, means what is the advantage of buffering the input, so that we'll discuss in this video. So first of all, what does it mean by input buffering? See, the input, whatever we are giving as input to the lexical analysis, has to be stored, and the same input we are going to be used in each and every phase of the compiler in different representations, but as it is stored in the secondary memory, bringing back everything is a time taking process. So that's the reason we should buffer this input so that we can speed up the process. So first of all, how this input is going to be read? So it uses two pointers. One is begin pointer, another one is forward pointer. So the forward pointer moves ahead to search for the end of the lexeme. Here lexeme is nothing but the shortest logical unit in the program. So for example, if you take the input like int I equivalent to 10 semicolon, then the begin pointer is at I, then the forward pointer will goes to until the regular expression is satisfying the maximum length. So whenever the blank space is encountered, of course the regular expressions doesn't have blank, then this would be treated as a lexeme. And for the next lexeme, again the begin pointer is pointing to this and the forward pointer is pointing here. Both are pointing at the same place once it is encountered the white space. And of course, these white spaces are going to be ignored as part of the secondary task of lexical analysis. So once white space is ignored, then both pointers at the pen. Again, this forward pointer moves to the next one until this lexeme is identified, or until the regular expression is satisfied or blank is encountered. So same way, like again, begin pointer and forward pointer is pointing to this, and same way here, the begin pointer and forward pointer. Then the forward pointer moves like this if it is satisfying the regular expression for the maximum length rule that we have discussed. So like how many lexemes it is going to have here? 1, 2, 3, 4, 5. So here lexeme means int, lexeme means I, lexeme means equals to, lexeme means 10, lexeme means semicolon. Lexeme means what are the actual characters. And what is the token of int, that is keyword? What is the token of I, that is identifier? Equals to is operator, 10 is number, and semicolon is special symbol. So this is how they store the input in the buffer and how they are going to detect the lexemes with maximum length rule. So, and as we have discussed just now, that so the input characters are always read from the second storage, but reading that is costly and time taking. So we have to read this data and we have to store in buffer. So if you store the data in a buffer for a while, so if you are retrieving the same data again and again, automatically the process will be speed up. Now to buffer that, we are using two techniques. One is buffering and another one is sentinels. So in first buffering technology, we are having two techniques. One is one buffer scheme and two buffer scheme. So in one buffer scheme, we are using a lengthy array, and so that the whole string will be stored in a single array, like one dimensional. Then we are going to move the buffers one by one. So what is the main problem with one buffer scheme? So once it reaches the boundary, right, then we are going to scan the next one. So for example, if you want to come back, then if the length of the lexeme is lengthy, then it is very difficult to identify the lexemes. So sometimes if your lexeme is too long, then it is going to cross the boundary of the buffer, right? Then to overcome this disadvantage, we are using the two buffer scheme. So here we are using two buffers to store the string, and we are going to scan the first buffer and second buffer alternatively. So if you scan the first one, then we'll go for the second. Like that, we are going to scan these buffers alternatively. So automatically there is no chance of exceeding the boundary until and unless it reaches the manual end of file. There is no right uh, thinking that okay, we are going to cross the boundary, because there is no boundary until and unless it detects what end of the file that denotes a boundary. Here, for example, if it crosses here, it will keep on going to the next one. We don't know that whether it's our input string or a different one. So there's a problem with the one buffer scheme, right? Then the second technique to buffer the string is sentinels. So these sentinels are like hidden tokens, and we are going to use in our right convenient way. Like, see, you are having the same buffer with a different kind of strings. So, and using the two different buffers may waste our space. So, what we are doing here, we are just using the EOF, the end of the file. So, to tell you that there is an end of that input string or the end of that particular lexeme. But this end of file will not be considered as part of the input string, and this end of file is not considered as part of the input string, right? And for every right part of the buffer, then the we are going to have the same beginning pointer and forward pointer. So now once it is done, we'll go to the next one. So same, the beginning pointer is at the beginning of the lexeme and the forward pointer moves, right? And you may get a doubt here. So what if you are going to have the end of the file in our input? So here end of the file is denoting what? The end of the particular part of the buffer, right? But what if I want to use the end of the file? Then you have to write EOF two times with the colons. So in that way, the first one will be treated as the actual EOF and the second one will be treated as a end of the buffer. So in that way, we can manually use this right EOF. So might be getting what does it mean? For example, the slash n is for new line. In printf, whenever you write like this, so slash n, then automatically what will be happen? It will take the new line. But I want to print a message that slash n. I want to display the slash n and I want to prove that it is for, I want to show that it is a new line. Then what we can write here? You can write like this: printf. Okay, use the slash two times n for new line. Then what will be happen in this case? So this is escape character. So whatever the next line we are going to have, that will not be treated. Then automatically slash and n will be printed. This slash will not be printed and it will not be considered as new line. So same way here, EOF is denoting the end of the file, right? So this is actual sentinel what we are using to buffer the input string in two different parts. But if I want to assume that if our input string is having EOF, then how we have to identify? Then you have to write the EOF two times by using these colons. So this is what exactly the sentinels. So in this video, we have discussed about input buffering and what are the buffering techniques. So next video, we'll discuss how we have to specify the tokens for a particular language.